So let's look at solving equations that have fractions or decimals in them. So when we have an equation that's dealing with fractions, what we want to do is eliminate the fractions. We want to get rid of them, but we have to do it in a very specific way so that the equation is still balanced. So what we're going to use is the least common denominator of all of the fractions that we see. So that smallest value that all of the denominators multiply up to. So let's look at this first example, and I'll talk about applying what is written up above there. So what we talked about before for finding the least common denominator, what can be helpful is taking the largest value. So here we have three denominators, 6, 3, and 6. So I'd take the largest of those, which is just 6, and I would list values until it's divisible by all of the others. Now, 6 and 6 are redundant, so we don't need to worry too much about that. But then what I'm looking for is a number that's divisible by 3. Well, 6 itself is divisible by 3, so that's just our least common denominator. I don't need to start listing out multiples because it already is a least common denominator. So, how I'm going to use this is I'm going to multiply absolutely everything in the equation by that least common denominator. So visually what I'm doing is I have this whole left-hand side of the equation, I'm multiplying that by 6, and I have this whole right-hand side of the equation, and I'm multiplying that by 6. So that's my balancing piece, is that it's still balanced because both sides of the equation are being multiplied by the same thing. Now the breakdown of this and how it appears is that on this left-hand side, this 6 is multiplying with each and every term. And again, this subtraction is separating the terms. So this 6 is going to multiply with the 1/6 x. So what I'm going to do is write that as 6 times that 1/6 x. I'm going to go ahead and keep that subtraction symbol in there. And then I'm going to have 6 times that 1/3. This right here is called the distributive property. It's that if something's multiplying across addition or subtraction, you distribute that piece across the addition and subtraction. Distributive property. But really, you can skip this step if you just keep in mind that everything gets multiplied by that least common denominator. So this will leave me with 6 times that 1/3. And then we have our equal sign, and then we're going to have 6 times that 5/6. And then we get to start simplifying down. So over here, 6 times 1/6, well, the 6's just cancel out, so all we're left with is a 1. So we have 1 times x minus 6 times 1/3. So 6 divided by 3, that's going to leave us with a 2. So that will just be x minus 2 on the left-hand side of the equation. And then we have equals 6 times 5/6. Well, those 6's will cancel out, and we'll just have 5 left over. So that's how our fractions eliminated, is by choosing this number to multiply by. Those denominators get kind of wiped out. And then from there, we end up with either a 1-step or 2-step linear equation that we did in the previous videos. So like with this one, trying to isolate x here. So I have that minus 2, so I need to add 2 to create a 0 there, and I just need to do that to the other side as well. So that will give me just x equals 7. Now for checking these, I highly recommend using the calculator because it can get a bit messy. It's good fraction practice, but let's go ahead and just throw this into the calculator. So we're going to have 1/6 times 7, which was our solution, minus 1/3. Now that's giving me a decimal answer out, but remember there's this convert to fraction button, and there we can see the 5/6. So that balances correctly, so that tells me that x equals 7 is in fact our solution. All right, let's do 2 more examples with this. So again, I need to find my least common denominator, and to do that, I would take the largest of the denominator, which my denominators are 4, 2, and 8. So I would take 8, and I would list multiples until I can divide in 4 and can divide in 2. Since they're all three different, I need all of them to go in. Now this is another case where just 8, well, that's divisible by 4. It is also divisible by 2, so that right there is my least common denominator. So least common denominator is 8. So what I'm going to do is I'm going to multiply everything by 8. I have this 1 for the x term, I have this 1/2, and this 5/8. So what this will look like is 8 times 1/4 x plus 8 times 1/2 equals 8 times 5/8. And then we simplify. So 8 times 1/4, so that can simplify to 2. So 2 times 1 is 2 times x plus 8 times 1/2. That's going to leave us with 4. So that'll be 2x plus 4 equals, and then on that right hand side, those 8s will just cancel out, so all we'll have left over is 5. And then I want to go through and solve for x. So to get the constants together, I'm going to subtract 4 from both sides of the equation. So I'll leave me with 2x equals 5 minus 4, which is 1. To get x completely alone, I would then divide both sides by 2. So x is going to be equal to 1/2. And then we could check our solution by plugging it into the calculator. All right, one more example here with fractions, and this one's just a little messier, but same idea. First thing I would do is look for the least common denominator. So my denominators are 4, 8, and 2, which is actually exactly the same as we just did in that last example. So our least common denominator is going to be 8 again. So I'm going to multiply everything by 8, and my pieces are x, and then this 3/4, and then there's my equal sign, then there's the 3/8 x, and then there's this 1/2 right here as well. So what this will look like is we'll have 8 times that term of x plus 8 times that term of 3/4. We'll have our equal sign, and then we'll have 8 times 3/8 x minus 8 times 1/2. And then we simplify. So 8 times x is just going to be 8x. 8 times 3/4, so to simplify down, 8 divided by 4 will leave us with 2. So we have a 2 times 3 there, so this will be a plus 2 times 3 is 6, equals 8 times 3/8, those 8s will cancel, so we'll just have that 3 left over with the x. And then 8 times 1/2 will leave us with a 4, so that'll be minus 4. All right, so this one has some pieces to deal with. So let's first group our variable terms together. Now I could either subtract 8x from both sides of the equation, or I can subtract 3x from both sides of the equation. Both are completely correct. You can go either way. What I'm going to do is subtract 3x from both sides, because with this smaller number, using 8 minus 3, we'll end up with a positive value. So I can just kind of avoid negative numbers a bit there. So I'm going to subtract 3x from both sides of the equation. So 8 minus 3 is 5, and then x stays hanging out there. And then we still have this plus 6 equals, so that 3x minus 3x turned into 0. Then we have this minus 4. Now I want to get the constants together. And since I'm solving for x, I want to move that plus 6 away from it. I want to get to the other side of the equation. So I'm going to subtract 6 from both sides of the equation. So on the left-hand side, then I'll just have 5x left over. And then -4 minus 6 is -10. Then to get that 5 away, we're going to divide both sides by 5. So x is equal to -10 divided by 5, which is -2. So that's a big one, but that's our work with fractions and equations. Find the least common denominator, multiply everything by that least common denominator, and then with that you'll end up with an equation that we practiced in those last 2 videos. Okay, for decimals real quick, there are 2 ways to go about this, and I'll show you both ways. Let's go with one way is to rely on the calculator quite a bit. So what we could do is treat this just like we did solving up above there, it's just we're working with decimal values. So something we could do here is I have my variable terms, I have my constant terms. So I want to get everything with my variable to one side of the equation and everything with the constants to the other side of the equation. So what I could do here is subtract this 0.06x from both sides of the equation. So on the left-hand side, that'll turn into 0, but I'll still have that 0.02 left over, equals 0.25 minus 0.06, and this is where you can use a calculator to help out. So if we type in 0.25 minus 0.06, that's going to be a 0.19, and then we have x still attached there, and then we have a minus 1.5. Now I'm solving for x here, so I want to get rid of that minus 1.5, so to do that I'm going to add 1.5 to both sides of the equation. And using a calculator for help, you can add these together in there, so 0.02 plus 1.5 is going to be 1.52, equals 0.19x, and then I would go ahead and divide both sides by 0.19, divide by 0.19, and again using a calculator, typing that in, we're going to get 8 out. So it's the same method, same process, you just will need to rely on a calculator a little bit more to get those values out. Now, the other way to go about this, if I just copy my problem down there, 0.06x plus 0.02 equals 0.25x minus 1.5. So what we can do is something similar to what we did with fractions, the idea of multiplying everything by the same number. And what this would come down to is if you thought of these numbers as fractions, like this is 6 100ths, this is 2 100ths, this is 25 100ths, and this is 150 100ths. Oops, I lost my x. There we go. So our least common denominator here would be 100, the idea of multiplying absolutely everything by 100. So we could write that out just like we did up above there. A little trick I like to use though is that what this is going to do, multiplying by 100, like you can see that this is going to turn into a 6, this will turn into 2, 25, 150. Basically all those denominators are going to wipe out there. What you can do is visually see this as well. It's like in order to get rid of our decimal there, I need to move to the right 2 spots. And if I do that, that'll give me 6x. In fact, I'm going to go ahead and write that down there. 6x. And then what I would have to do is move the same number of spots as I just did there. So here, move to the right 2 spots, and that'll give us 2. Over here, move to the right 2 spots, 25. And then this last one, move to the right 2 spots. It has to be the same number. And notice there's a gap there. So what we would do is just fill in the blank with a 0. So this would be 150. And now we have something with numbers that are a little bit easier to work with. without a calculator, though you might still need a calculator for support. But the idea being we would subtract 6x from both sides of the equation. So then we would just have 2 equals 19x minus 150. Then we could add 150 to both sides, so that it's 152 equals 19x. Divide both sides by 19, and we get x equals 8 for our solution. So you can even see the numbers end up being pretty much the same. It's just decimal form versus whole number form. But it's just the idea that we'd have to move the same number of decimal places for each piece, and then you can work with those whole numbers. So I'm going to show an example with this kind of same setup here with this next one. But again, you could go through it just using the calculator, and that's fine too. So what I would do is I can see, so while here we could just move one decimal place, the key is that the others need to move 2. So use the larger value. So if we need to move 2 here, then we'll move 2, 2, and 2, which would give us a 0 to kind of fill in the blank there. So moving by 2, that would make this 14x plus 12 equals 35x minus 240. And now we can solve and not worry about decimals. So I'm going to subtract 14x from both sides. So that'll leave us with 12 equals, and what this will be, 21 minus 240. I'm going to add that 240 to both sides of the equation to get it away from x. So that will make this a 252 equals 21x. Then to get x completely alone on one side of the equation, divide both sides by 21. And that will give us x equals 252 divided by 21 in a calculator should give us 12. And that would be our final answer.